I'm sure many of you have seen this pink cancer ribbon symbolizing breast cancer. Maybe you know someone who has had breast cancer, but you don't know much about it. In this video, we will discuss mutations in certain genes that could increase the risk of breast cancer, as well as a genetic test that could show if one has the mutated genes. But before we dive into all of that, let's go over some background information about breast cancer. Breast cancer begins to develop when certain cells found in the breast begin to accumulate uncontrollably, and this forms a tumor in the breast. The breast is composed of two epithelial cell types. This cancer is more commonly known in women, but men can also develop it. Ductal cancer is the type of breast cancer that can be seen developed in women and men. Lobular cancer is seen mostly to be developed in women. The most common cause of hereditary breast cancer is a mutation found in the BRCA1 and BRCA2 gene. These genes are known as the breast cancer genes. There are many more gene mutations that could cause one to develop breast cancer, but these two are most frequent, therefore we will focus on them. Mutations can cause these genes to stop working properly, and this causes an increased risk in breast cancer. The mutated gene can be passed down from either the mom or the dad. According to the American Cancer Society, only 5 to 10% of breast cancer is hereditary, so inherited gene mutations known to increase the risk of breast cancer are pretty rare in the general population. That means 90% or more of the breast cancer cases are caused by environmental factors. Factors such as being exposed to toxic chemicals and pollutants, a sedentary lifestyle, and alcohol consumption can all influence the breast cancer development.
The variations tested by 23andMe for breast cancer are the variants 185DELAG and 538INSC on the BRCA1 gene, and the 6174DLT variant on the BRCA2 gene. Today, we will be looking specifically at the 6174DLT variant on the BRCA2 gene. This genetic variation impacts the structure and function of the BRCA2 gene. The BRCA2 gene makes a protein that acts as a tumor suppressor, which helps prevent cells from growing and dividing too rapidly or uncontrollably. The protein that BRCA2 produces is also involved in repairing damaged DNA, acting with other proteins to repair DNA. By repairing this damaged DNA, the BRCA2 protein is crucial in maintaining a cell's genetic information. This protein is found in almost all cells. When the BRCA2 gene is mutated, it leads to the BRCA2 protein not being able to function normally. Mutations of the BRCA2 gene lead to proteins that are abnormally small and non-functional, meaning that less of the protein will be available to repair damaged DNA or fix mutations in other genes. Over time, these defects will lead to uncontrollable growth and divide of cells, leading to tumors that can cause breast cancer. In the general population, 1 in 400 people have the BRCA variant. Most people with BRCA variant tend to not have the 6174DLT variant and the BRCA2 gene, since there are over 1,000 variants of the BRCA genes that can lead to breast cancer. According to 23andMe, women with a variant have a 45 to 85% chance of developing breast cancer by age 70, and up to a 46% chance of developing ovarian cancer by 70. Men, who have a lower chance of getting breast cancer in general, have an 8% chance of developing breast cancer if they have a variant. There are many other genes that impact the risk of this trait that are not tested by 23andMe, including many other variants on the BRCA genes, as well as variations in the genes P10, TP53, CDH1, and STK11. Most hereditary cases of breast cancer are due to mutations on the BRCA1 and BRCA2 genes, however.
There are a total of 2,654 SNPs that affect the BRCA1 gene and 3,151 SNPs that affect the BRCA2 gene. There are dozens of additional SNPs that will impact the BRCA1 and BRCA2 genes traits that 23andMe does not test for. According to the 23andMe website, they only test for 3 variants in the BRCA1 and BRCA2 genes, this being 50% of the BRCA1 SNPs and 23% of the BRCA2 SNPs. Thus, if someone was to take the 23andMe test, they'd still be left in the dark with 85% of the BRCA1 SNPs and 77% of the BRCA2 SNPs. This clearly is a vast majority of the SNPs being neglected. Both BRCA1 and 2 act as tumor suppressors, or in other words, work to prevent cancer in the body, in this case, breast cancer. They are expressed in the alveolar and ductal epithelial cells of the mammary glands in the body, and about 1 in every 500 women in the United States has a mutation in either her BRCA1 or BRCA2 gene. Furthermore, if a person's parent has the BRCA1 or the BRCA2 gene mutation, they'd have a 50% chance of having the same genetic mutation. For our genetic test, We will test the RS80 35 74 42 SNP for the BRCA1 gene and RS49 87 11 7 for the BRCA2 gene. Because not only does 23andMe not test for it, but neither does any other genetic testing company that is currently on the market today.
Genetic tests provide limited information about inherited conditions like cancer. Variations that impact the trait may be unknown. The results are sometimes uncertain or could present abnormalities in the BRCA gene that have not yet been associated with cancer. A positive test means one is higher risk for developing breast cancer but doesn't ensure one will 100% develop it. A negative test result doesn't mean one will not develop it. As mentioned above, environmental causes are a large factor in the development of breast cancer. With all of that being said, genetic tests cannot predict your exact level of risk for development because it goes beyond just inheritance. According to the National Cancer Institute, about 13% of women in the general population will develop breast cancer sometime during their lives. By contrast, 55 to 72% of women who inherit a harmful BRCA1 variant and 45 to 69% of women who inherit a harmful BRCA2 variant will develop breast cancer by 70 to 80 years of age. The National Library of Medicine stated women with the germline BRCA1 and BRCA2 mutations have 5 to 20-fold increased risk of developing breast cancer. Mutations in the BRCA1 and BRCA2 gene will cause the most increased risk, but mutations in other genes such as ATM, PTEN, and CDH1 may cause a slight increased risk.
There are certain limitations to consider before participating in a genetic test. Scientifically, genetic testing can only provide limited information about possible genetic results. Some tests may not be able to show symptoms of a possible disorder or how severe the symptoms could be. Likewise, there may often be a lack of treatment strategies for certain genetic disorders after they are diagnosed. This could leave some participants feeling helpless. There are also ethical limitations to consider. Financial, emotional, and social factors are all aspects that can come into play when considering genetic testing. After receiving results, some people may often feel frustrated, depressed, scared, or even rejected. For example, genetic testing can sometimes create hostility or tension in a family due to the genetic testing results showing information about other family members, not just the person who tested. Results can also place pressure in the workplace. Genetic discrimination in the workplace and even insurance issues can also arise after testing. From an article from Medline Plus, genetic discrimination can happen when people with gene mutations are treated differently by their workplace, employer, or insurance company. End quote. This creates fear of discrimination among anyone who's considering or participating in genetic testing.